Very cool. Well, you ready to move on?
Absolutely. Well, it's wonderful to have Jason Kim back.
More conversations. Yes, indeed. Jason Kim, my new friend that I just found out about today. Hello, my friend from Millennium Space Systems. Great to have you along. It's all yours. Take it away.
I'm honored, Scott. That means a lot to me coming from you. And it's always great to hear from Dan Hart. He always has very thoughtful things to say. And he's part of the local Los Angeles community of companies that are in aerospace and defense. And I know a place that where you could get your own small satellites. It's called Millennium Space Systems. So
you'll sell it and they'll put it up.
That's right. Well, good afternoon, everybody. This afternoon, I'm honored to host a Fireside Chat with Dr. Mung Chiang, an American engineering researcher, educator, technology entrepreneur, university leader, and foreign policy official. Dr. Chiang is both executive vice president of Purdue University, great school, and the John A. Edwardson Dean of its College of Engineering, as well as the Roscoe H. George Distinguished Professor of Electrical and Computer Engineering. And previously, he was the Arthur Legrand Dottie Professor of Electrical Engineering at Princeton University, another great school, and an affiliated faculty member in applied and computational mathematics and computer science. And we have some limited time here, so I want to get right into the questions. So is Dr. Chiang on?
Well, he's not with us just yet. He's trying to solve some technical problems. So maybe before he comes on, maybe we talk a little bit about Millennium Space Systems again, and this problem that they were just talking about before, this sustainability in space, satellites, et cetera. I know you guys are involved in a great deal of that work, thinking about if we put it up, what do we do with it? How do we take it back down? How do we not run into each other, et cetera? So I was wondering maybe, Jason, if you might talk a little bit about Boeing, your Millennium Space Systems, and how you're involved in that sort of thing, how that plays into your efforts.
Sure. No, thank you for the opportunity. Millennium Space Systems were a fast-moving, agile, small satellite constellation company. And we have had some recent success with things like flying our drag racer demonstration, where we flew two identical satellites. One had a 70-meter tether, the one that Dan Hart was talking about earlier today. We actually flew one back in November. And the experiment was a controlled scientific methodology experiment where you've got two identical satellites. One has a tether, one doesn't have a tether. It turns out that the tethered spacecraft augured in much faster within single-digit months, and the other one is still up there. So we were able to quantify what a tether is able to do with very low size, weight, and power accommodations from a small satellite or even a large satellite to deorbit that satellite so it doesn't become a piece of debris at end of life. There's other ways to deorbit with propulsion and drag, but this is a new novel way to do it very, very efficiently and responsibly. And in addition to that, there's all kinds of very sustainable fuels, like Dan was talking about, the aircraft using sustainable fuels. Spacecraft also have some fuels that are green. And so we have experience with green fuel. We have experience with water-based fuel, if you can imagine that. And so there's a lot of great environmental, social governance type technologies out there in space that we are having a lot of great success with, and the entire industry is learning about and trying to use more of.
And so this is a satellite that you can get the cost down to, maybe a large corporation, maybe a small country. The country can have its own satellite. Is that right?
Yeah, I think that you're going to see more of that. You're going to see a lot more of constellations from Millennium Space Systems, where the price point per unit is coming down in price because you're getting those economies of scale and you're getting a lot of efficiency in the high volume production line. And so that's something that you're going to see a lot more from our company, and you're seeing it from various aerospace companies today as well.
Okay, well, wonderful. Now, it's funny. I saw a satellite with a long tether being drugged behind it, and it went into the atmosphere, the ionosphere, whatever, and it created power.
That's right.
Yeah.
Yeah,
So
it's a little known fact. I'm glad you brought that up. So electrodynamic tethers basically harness the interaction with space physics. So there's a plasma environment that's above us in the heavens. And when you actually have a cathode and anode at either end of a long electrodynamic current carrying conductive tether, you could actually complete a wire in space and interact with the Earth's magnetic fields and cause a Lorentz force, like you studied back in physics, right?
Mm-hmm. Yeah.
That's actually something that has been demonstrated in the past in space, if you believe it.
Well, the first one I saw, it basically blew up. It melted. It generated so much energy, right? That the first.
You actually could put energy into the system to basically thrust a system or drag a system. You could also harness energy from it as well when you're dragging. So it's a pretty unique and compelling technology that I think you're going to see more of in the future.
Absolutely, and it can power others. I mean, it could be a near opportunity, for batteries, et cetera. Generate the batteries there.
That's correct.
Take them somewhere else. So I'm sure that's another project that you're working on, right?
We would be blessed to work on projects like that. It's like sci-fi, but in reality, we're doing it.
Yeah, you're right on the cutting edge. So I think we've got the good doctor here with us. Thank you for those few moments, and we look forward to your conversation.
All right, great.
Hi, Dr. Chiang.
Wonderful. Hi, how are you?
Well, we just completed a great introduction, and without further ado, I'll just go straight into the questions. So thank you for being here. To start, can you please share a bit about Purdue's College of Engineering with us?
Oh, wonderful. First of all, thank you so much for the invitation to be at the America's Future series here, and great to have a conversation with you and other panelists. And congratulations, Jason, on all the wonderful things that you and your company have been able to do. Now, Purdue Engineering College is the largest top 5 college of any discipline ever ranked. And we are now top 10 in 5, number 4 in the United States for graduate and research program. We have almost 16,000 engineering students in residence and another 2,500 online. And we are proud of this pinnacle of excellence at scale to be able to do the most cutting edge research and to educate the largest number of engineering students among any of those ever ranked top 5 in the country.
That's wonderful. Thank you for sharing it. It sounds like there's a lot of exciting things happening at Purdue. As you know, the industry I'm in, aerospace and defense, we're facing a shortage of engineers, and it's not a new problem, nor does it really start in industry with all the prerequisites for college. It seems like you have to catch students very early. You got to catch their interest very early, maybe like late junior high or very early high school. So I'll ask, what do you think has to change in order to help us grow our engineering base?
Yeah, one thing that seems that my volume is not very well captured. I'm going to try to see if I can do something about that here. All right, is this a little better? And I hope this is working well now. Jason, can you hear me well? All right, great. Well, you're exactly right, Jason, that the biggest talent pipeline supply chain goes back to K-12. And we need to have here, especially in America, a lot more focus of students who will be encouraged to pursue STEM fields. And engineering in particular is not the same as science or math either. There is a lot of problem-solving mindset involved. And most of the middle school, high school students do not have much of an idea of what is engineering. So we need to bring some engineering curricula into high school, and we need to train all the young boys and girls from early on to be interested in hands-on experience, in problem-solving mindset, and the ability to deploy what they learn in a quantitative field to societal's grand challenge problems. This got to start from K.
Yeah, like you said, interest in STEM education definitely starts well before the university level. It starts with K. I can see how that's the case, and really not just starting, but maintaining and sustaining those students in STEM. So the next question I had, Dr. Chiang, was what impact does this early education involvement have on the College of Engineering?
Well, one is that we actually do reach out actively to K-12 community, but also in the sense that we work with nearby community. We try to innovate learning and education. For example, we all know that the post-pandemic demand from students and parents, employers, they want to see online learning to be effective at scale, and they want to see virtual learning real. So on that front, we have deployed AI agents using machine learning for human learning, individualization, recommendation, prediction. We have deployed an educational digital twin and virtual laboratories to make virtual learning real. They also want residential learning to be extraordinary. What is the value add of residential learning? It's more about uncovering yourselves and the world more than covering certain knowledge base. So we have to use experiential learning in and outside of classrooms so that they can use what we call GRIT, G-R-I-T, for global research, industry co-op, and team-based project learning to enhance what they typically learn in classrooms and labs. I'm proud to say that among the 11,000 plus undergrad engineering students at Purdue, we now have almost 80% of them doing at least one, if not multiple, of the GRIT experiential learning.
That's something I definitely want to hear more about, Dr. Chiang. And I like the acronym because that's what we're looking for is future workforce that has a lot of grit. And, selfishly, I want to see more qualified engineers join the workforce. We all need it in industry. And so that leads me to my next question is, how can both academia and industry help?
Well, we got to work together. We at Purdue Engineering just this morning unveiled a new Center of Excellence and Industry Consortium on composite additive manufacturing with a lot of applications to the aerospace industry. And we look at a hexagon of relationship between industry and universities. One is the phase of recruiting and curriculum update together. Let's design the next phase of curricula together. Two is online learning, workforce development, upskilling of your current employees through online. And three is research collaboration. Four is intellectual property rights, co-generation licensing. And fifth is philanthropic support, especially scholarship for minority and women students in engineering. And sixth is economic development. We welcomed, for example, Saab, Rolls-Royce, Northrop Grumman, and many others aerospace companies this year to create Purdue's aerospace district. When they are here with their own manufacturing sites, they employ people. And these could be students, could be co-op, could be full-time employees. And we get to create knowledge and jobs together. So it is a hexagon of multidimensional relationship between companies and universities.
It's a great perspective that you had, like that, the hexagon, multifaceted way of solving that problem. I'm taking a lot of notes right now, like a good student. Right now, there are a number of countries that have high numbers of engineering graduates, but we'll be hard pressed to find a job in the aerospace and defense industry with companies who have contracts with the U.S. Department of Defense. What can we do to bolster the number of our engineering graduates in the U.S.?
Yes. Well, national security technology is one of the 5 pillars that President Mitch Daniels of Purdue University and the Board of Trustees declared back in spring this year, one of the 5 pillars for Purdue's next moves. And we know how important it is to have domestic students, clearable students, perhaps at all levels, undergrad, master, and PhDs. So we are creating pathways for those who are in the uniformed services to do a PhD here. It's called a PMRI. If you Google that term, Purdue, you see that we're welcoming about almost 100 of them today. We're creating classified dissertation pathways as well. But that is a bit too late by the time it gets to graduate school. Again, we need to go back to K-12 and to actively work with the Department of Defense and the National Security operations to encourage students to pursue, for example, at least a master degree, a post-bachelor degree. We also need to give them more scholarships and fellowships. There are some out there, we thank them very much, but frankly, there got to be more, whether it's in aerospace or in semiconductors or in cybersecurity. And we need to have a bit more collaboration between the military academies, such as, say, Air Force Institute of Technology, so naval postgraduate schools, with civilian universities such as Purdue. And we are working on that. But I think that it is exciting time in your field, for example, when students look at anything that can fly today, they get energized, whether it's the vertical takeoff landing, whether it is the autonomous and Zhong, maybe it got a little bit farther, hypersonic and near space. It could be going all the way out to cislunar and from the moon to Mars. People are energized, and students, young people, are energized by things that fly. And this decade, arguably, is the golden age ever since Neil Armstrong, which, by the way, is also a Boilermaker. And we just celebrated 2 years ago the 50th anniversary of landing on the moon. And this, I think, is another golden age decade for the aeroastrospace.
Yeah, I agree with you there. That's very impressive. I always say that for the new workforce, I encourage people to go watch a launch, because there's something special about designing and building a satellite and then watching it launch and then come alive. And it's really a life-changing moment, and it's very climactic too. Not a lot of industries have that kind of climax, and even after the launch, you operate the satellite and you see the satellite take life. And so that's something that maybe we could get more Purdue students and students from other universities to go witness those type of launches, whether it's at Vandenberg or the Cape or at Wallops. That would be phenomenal to inspire the future workforce.
Oh, we should do that. By the way, Jason, as you might have heard, that Purdue Engineering hosts Zucrow Laboratory, founded in 1946, the nation's largest academic propulsion combustion lab. We have one of the startup companies here next door to the campus, which has new propulsion technologies, and their launching pad is right next door to the additive manufacturing laboratory facilities. And in the Virgin Galactic launch in July this past summer, 2 of the 6 crew members, the 2 female astronauts, were both Purdue alumni, Shrisha Bandla and Beth Moses, and they invited some of us to go there and witness the launch. As you said, there's nothing quite like that.
Sounds like Purdue's on fire in a good way, with all the astronauts that are going up. And so it sounds like a good place to go if you want to be an astronaut.
Yeah, we are the cradle of astronauts, 26 and counting now.
Wow.
And by the way, it takes the whole village. It's not just the astronauts, but everybody working there. And that's why we launched the Purdue Cislunar Initiative. Again, if you Google Purdue Cislunar Initiative, you will see how we're advancing the research, the learning, and the industry society engagement. In fact, you'll probably see a link to the upcoming Purdue Space Day as well. And this is a long-standing. The Cislunar Initiative was 2 years ago started, and the Space Day has been long-standing. At least in the Midwest, we get hundreds of students every year. It was physical, now it's virtual and hybrid, to come here. These are, I think, 3rd grade to 9th grade or 8th graders. And they come here, they go through 3 experimental stations, including a opportunity to launch their own tiny rocket. Doesn't fly perhaps that far, but nonetheless, it is a very impressive learning experience. And some of them indeed wants to come back as Purdue engineering undergrads, hoping that one day they will be either astronauts themselves or be an essential part of the team.
Great, great. Thank you for sharing. In the spirit of STEM and geometry, I want to circle back to your hexagon comments.
Mm-hmm.
And the next question is about, are you able to give us some examples of successful engagements that industry has had with engineering college students, like capstone projects or mentoring or hackathons?
Yes, absolutely. We engage with many companies that are in the space industry, and Blue Origin and SpaceX and Virgin Galactic, they all have learning experiences with our students. We have something called vertically integrated projects from freshmen all the way through senior years that work together on teams. Some of those projects are sponsored or created by some of these industry partners. Another good example is in the space of hypersonics. This past summer in August, we had a trifecta of hypersonics at Purdue, including the hosting of Hypersonic Summit 2.0 with DoD and all the major players, including Rolls-Royce announcing the largest economic development deal in the history of Purdue University in hypersonic high altitude testing and hybrid engine as well, and in the launch of HGTC, Hypersonic Ground Test Center, which is an independent nonprofit consortium defined by industry members and hosted on the neutral Switzerland ground of Purdue University. And as these hypersonic moves proceed, we see a lot of student interest, and we're going to create a lot of good projects for students, undergrad all the way to PhD and postdocs to work on, along with all these, in this case, hypersonic companies. But we do that for all related to space.
I just wanted to give a shout out to Boeing, that Boeing is a sponsor of Purdue Space Day. And
Yes,
in Millennium Space Systems, we have a lot of legacy Purdue graduates, and so we're very proud of that. Which brings me to the next question, which is, I understand that your college graduates the second largest group of women engineers in the U.S.
mm-hmm.
You've already mentioned some great women astronauts.
Mm-hmm.
What has the College of Engineering done to enable that success?
Well, first of all, let me just echo what you said about Boeing. Boeing has been a long-standing and outstanding partner with Purdue Engineering through decades. We have a Boeing lecture devoted to that relationship. Also, when Saab unveiled their T-7A trainer jet fuselage manufacturing site here 2 weeks ago, Boeing was here as well because Boeing is the prime in making the next generation fighter jet trainer jets for U.S. Air Force. This morning, the Additive Manufacturing Industrial Consortium, Boeing, and also Dassault Systems, which produces a lot of the virtual physical interaction, something produced very strong at to Boeing was there. So really appreciate that relationship with Boeing and Boeing companies. Yes, we are the place that gave rise to the first Women in Engineering program in the United States in 52 years ago. And we also have the nation's first student chapter of Society of Women Engineering program. In fact, just last Friday, we participated substantially at the annual conference of SWE, Society of Women Engineers, getting 9 awards by our students and alumni. And I think a key here is to recognize the importance of pipeline and community. I mentioned a bit about the community side, and then the pipeline is also important. Role models is important. We had Lillian Gilbreth, the first female faculty member in Purdue Engineering and the mother of industrial engineering in the modern age. And now we have over 100 female engineering professors. We are proud of everything they and the students have been doing, and we want to continue the support to make sure that we will be not only the second largest, maybe one day the largest source of women engineers, but also a place where access and success is very well provided to all of them.
That's really exciting. It sounds like those role models are really inspiring to the students, and hopefully the students across the country that are seeing what you're doing at Purdue and all the opportunities at Purdue, the impact of these high visibility role models, and hopefully those students want to enter the space workforce. You know, it's truly an exciting industry. Like I have said before, in some cases it's like sci-fi, but we're actually doing it today. And our industry has come up with satellites that we rely on today for the things most people probably don't even realize, like GPS and whatnot. What's the best way for students to prepare for this type of industry?
Well, I think that the best way is to enhance your curiosity. And learning doesn't end when you graduate from college or graduate school. And you got to keep learning. And you got to keep an open mind to be an innovator, to be an inventor, to be an engineer. So it's less about perhaps the knowledge that you cover, but is the curiosity that can help you to keep uncovering new things.
Yeah, I think from my perspective, I think it's the aptitude to problem solve. I think that's the thing that we're always looking for in industry for graduates. It's not necessarily always getting the right answer. It's also how do you look at the problem and define the problem and solve the problem. And based on my industry experience, I fully agree with what you said. And the more that students can seek out real world experiences, the better. One way of doing that is internships at Millennium Space Systems. We offer paid internships every year, and our interns actually do real work on our systems. And so that's another opportunity for folks to really hone their skills and learn a lot and take risks and learn from them. In addition to these internships, what do you think we can do better to support the pipeline of engineers while they're in school, while they're at Purdue or other universities, and also for those about to enter the workforce?
Well, I think that we should have, by the way, a great internship program pipeline with Millennium Space Systems. We started a new modality this year called Learning While Working, recognizing the flexibility that virtual learning gives people, that we allow them to take a whole full year of co-op, basically full-time working, and not just for one summer or 10 weeks, while being allowed by their employers to take on Fridays and weekends a couple of courses back home online virtually, so that they can keep up on their learning as well. So maybe we should have a pipeline of such learning while working co-ops into your company. And I think we can work together on many fronts: Space Day, engagement, understanding how high school curricula can update themselves, and thinking about hands-on learning, thinking about AP credits, thinking about the entire ecosystem with K-12, university, including grad school, and companies working together. The key, I think, is to get out of the typical modality of curriculum that has been there for a long, long time, but recognize that, look, the space is moving very rapidly. Used to be just NASA. Now there are so many private sector investment and successes. It used to be quite long time scale and quite rigid, and now that's dramatically changing. And you mentioned GPS, and now there's so many other new inventions, whether it is the LEO satellite constellation for global broadband coverage, or it is the ability to have a space tourism and the ability to clear pathways and navigation between here and the moon and beyond is so dynamic. So I think we got to make sure learning catch up with the speed of business, the fundamentals stay the same, perhaps, but a lot of the hands-on, just-in-time learning got to start motivating from the up-to-date examples.
Those are all great considerations for us in industry to think about. And I want to be mindful of time, so I'll ask just one final question. If we could get your wisdom on this, what's the best advice you can offer to graduating engineers seeking jobs in the industry?
I'll say never stop learning. Never be just relaxed and kick back and say, I got my degrees. Always keep learning. Now, that may mean you want to get an online master degree. And by the way, yes, Purdue Engineering also is ranked the number 3 in online graduate degrees in engineering. We have the nation's number 1 electrical, computer, and mechanical. And maybe it's not a degree. Maybe your employers will support you, even pay for a certificate. Just a couple of courses and get that together. So that's number 1. Never stop learning. Number 2 is give suggestions to universities, to us. I'm all ears. Give it to corporate leaders such as Jason here to say, yes, this is perhaps what you guys can do together with all of us, and make sure that the corporate and university leaders, she or he understands the needs coming from students so that we don't cease innovating how we discover and disseminate knowledge. Like, for example, I know semiconductor is important to the space industry as well. The chips that go in so many parts of your systems. Well, Purdue just announced the nation's first dedicated set of degrees in semiconductors, online master, undergrad minor, and online certificates. That's because we heard from people like those in the audience right now to say that, look, we need to really have an in-depth understanding of the design and manufacturing of semiconductors as a dedicated degree. And third and last, I'll say, well, understand the policy implications. We have to make sure that American leadership and American policies will also go hand in hand with the nerdy engineers. So for example, Purdue this summer is in a busy summer, I guess, launched the nation's first tech tank. It's called the Center for Tech Diplomacy. If you go to techdiplomacy.org, you see, this is a think tank devoted to the intersection between emerging technologies such as space with foreign policy in particular. There's also a lot of domestic policy questions. So as engineers, I think we also have societal responsibility to make sure that technology advances freedom, to make sure that space technology is keenly aware of societal implications, and policymakers get to listen to the engineering side of the story and work as one team in this country.
I want to thank you again for your time and insights today, Dr. Chiang. I learned a lot. I hope everybody else got inspired as well. I wrote down a lot of notes. We have a lot of work to do, but we all look forward to partnering with Purdue.
Well, we're very excited to do just that. And thank you again for inviting me to be on this truly exciting panel at a great time.
Thank you, gentlemen, both of you. Doctor, we appreciate your involvement. No, thank you so very, very much. We hope to see you again. Very, very nice. And Jason, thank you again, my friend. Stay well. And again, thanks for all your involvement today. We very, very much appreciate it. Good stuff, huh, David?
Fantastic. And, both Purdue and Boeing, they have great cultures, and they're very, very innovative. And I know the Millennium Space System is hiring. And if you're at Purdue, you need to be talking to Jason and any of these other schools. They're at the cutting edge. They're innovative. I've known Jason since his days. I mean, I think he was at Boeing first, then he went to Raytheon, and now he's leading this business. And talk about a gracious, brilliant, hardworking, dedicated leader. And the company culture reflects the leader.
That's fantastic. Fantastic. That's good stuff.